when we know DC, degree of curve, we can, according to this picture, to calculate RT, LC. We know that R is equal to what?
Radius.
No.
Yeah.
R.
Radius of the arc.
Yes.
Yeah.
So we can, when we got DC, we can calculate R. Yes, radius.
Yes. You see that is there.
When we know radius, we can do tangent. Okay?
Sorry, Marshall.
This R times get half it. When we get T.
Okay, yeah.
L line length like this. We can use this equation to calculate length of curve. The LC, this length of curve is, we can use this equation to calculate R sine half of that. We can know this. Yes or no? Length of chord PC to the length of PC from PC to point tangent.
No.
No. This is the R. Sine half that is this. The length from the midpoint of chord to the point of curve. We can do that. The PI pointed to this is R.
How? From E to M.
What's that?
That time, whatever the thing is. And then from down to the radius. Because it's finding only E. So,
E.
Radius minus cos. Yes.
Yes or no?
It's R or 12.
R.
Divided by cos.
Cos.
R.
R divided by cos.
by the cosine.
Cosine theta over 2.
Minus R.
So,
Minus R.
which one is R again?
Why do we get that R? Oh. I think.
Yes or no?
No.
Yeah. Let's take our time. Yeah, this is the internet as well.
Right. Right? Yeah.
So
We can calculate this relation to what? This.
minus
What?
where the minus one come from the minus R, right? Yeah,
Please.
You know,
No. How do we get to 4?
No, the 4 is the number of this thing. From E to M, then from M to the
So this thing
over 2, then from the
relationship from this to times. Okay.
Yeah.
PC is we can use this equation to calculate yes on PR subgrade T and PC.
See. Oh yeah.
Yes or no?
I minus PT. VR minus.
PR PC plus T is equal to PR.
Ah, yes.
Yes,
Yes.
we can use this equation
These are coordinates.
to calculate or compute the PT. Now we can see example. Example 1. A horizontal curve is to be designed to connect two straight sections of a highway. The PI is originally determined to be station 180 and depth is 30 degrees. If the radius of the curve is fixed at 403.15 meters, what are the station numbers of PC and PT and the length of the curve? We can spend 5 minutes to calculate.
Horizontal curve is to be designed to connect two straight sections of the highway. The PI is originally
We should know the station. This is station.
PI. PI is originally determined to be yes. Station 180. 80 plus 00.
And the length of the cube.
Okay. Now, from the formulas that we have, can we go to the formula?
No, the phone I have.
Here's the formula. Can I see the formula?
This 360 degree, and this is 180.
No. We can just let DS, DC. DC is the substance. 这是肯定的。
So it's the same thing.
Yes. When the R is
I don't think first.
yes. PI is point of a interchange
Section.
intersection.
Yeah.
Yes.
Can I see the PI formula? The PI. PC is equals to P minus T, right? PC is equals to PI minus T, and PT is equals to
PC plus L.
it's equals to PC plus L. Right. Thank you. So PI we have 180. 180 plus
Ah, it's 3.5.
5.
Something 342 something. Don't mind. Very fast.
Is it PT minus PI minus see that is
Now we can see this.
Where's the log?
This figure.
See, I'm
yes, T.
Yeah, PC is equals to P minus T and PT is equals to PC plus L.
T is the tangent distance. API is fixed at 403 millimeters. That's what the tangent doing.
Okay, we have 10 minutes rest. We use this time you can calculate or compute.
T is equal to R tan N over 2. So it's equal to R. The radius.
Last break. Stop video and answer the question.
It is not like the calculation formulas. Oh yeah. Next, we can use this formulas to calculate.
In simple is okay.
We can know that the deflection angles can assist with the layout of a horizontal curve. The process is useful because it allows the curve to be developed incrementally with the chord, without locating the center of the curve. So we can know any point on the curve. Yes or no? Use this.
Yes. If you find y, then you find x.
We can know
Then
x.
we can know y. Yeah. Then we can find PL. And we can find I. We can find P.
When we know there are radius and x, we can know y. Then x, y, and x, we can use these formulas to calculate. Now, we should know that arc length. The arc length is the length along the curve to the point of interest. It is any point on the curve. Chord connects any 2 points on the circumference of the curve. For deflection measurements, the chord starts at the PC and connects in a straight line to the point of interest. Deflection angle. The angle enclosed by the tangent and the chord with the vectors and the PC. Each incremental deflection angle is equal to half of the central angle of the subtended arc. The deflection angle defined by the arc connecting the BC and the PT is half of the overall intersection angle of the curve. So, we should know deflection angle called arc length and central angle, the angles subtended by the arc. Tangent length, the distance along the tangent from the PC to the point on the tangent then is perpendicular to the point of interest. Tangent offset, the perpendicular distance from the tangent to the point of the curve. So, just these parameters, we can use this figure to understand. Now, there's another compound horizontal curves. The parameter of larger radius curve subscribe 1, but the smaller is subscript 2. These two figures are different. Yes or no? On this figure,
Yeah.
there are
Oh, yeah.
is larger than the right part,
Yeah.
but this is
Less
the
than.
right is less than the right.
Yeah.
But we should know that the larger radius is the subscript is 1. The smaller is 2. But it is not the R. The larger R is right or the left. The subscript is 1. The larger radial curve is adjacent to PC. The smaller, this different figure. This is the large adjacent to PC, and this is the smaller
Adjacent to PC.
radius curve is adjacent to PC. We can use these formula or equations to calculate TA and TB. TA is the largest.
Right, yes.
Yes or no? Is equal to the large radius.
Yes.
But TB is the smaller. So we should know.
So TB and TB are the same size.
No.
We can use this. When we know R2, R1, R, get 2, get 1, we can use this formulas to calculate TA and the TB. Spiral horizontal curve. We should know that this tangent to spiral point TC, TS, and spiral to curve point SC. Curve to spiral point, spiral to tangent point. This TC, SC, spiral to curve. Curve to spiral. And spiral to tangent point.
ST.
This is more point we should know, just like SC and CS. curve, horizontal curve.
Central angles.
That central angle.
This is
That's C, simple curve angle. We can use these formulas to calculate different parameters. Since S is spiral angle, K distance, P natural offset, this X is tangent to the end of the spiral, YS is tangent offset. It's more difficult. But you should know when you
No, another one is big. Yeah, it's really big. I will make the flash card that I will take it from. Flash card.
But you know what I'm thinking? How did he send it to me through?
so this book,
How do you say it?
How do you send it?
this book, Highway Engineering, Planning, Design, and Operations. We should read.
It can transfer.
No, the third one.
This.
No, the third one, like, you cannot send it to.
When you have another any problem, you can read this book.
Okay, yes.
Okay?
I'm engineering, yeah. Sure.
Give us more examples.
Okay.
In this book, you can spend time to read it. Okay?
Yeah. This is the third one. We have two books. Now we have three.
We have three.
Everybody send 10 pi.
This
Because
is
we need to buy data to send the book to you. Including those
Just
online.
like this.
Send me 20 pi, those online.
Just like this example, spiral horizontal curve.
Yeah.
We have spent time to read it and to understand how to calculate it. Okay?
yes. Medium quiet. Which online book you're talking about?
The biggest one. All of them, give us your 10 pi.
Okay.
Too much.
It's too much.
Those
Alright.
ones I think $20.
The horizontal. Another question we should consider. Problem, just like super elevation. Normal drop and super elevation. 这个里面
This is normal crown, super elevation.
normal crown is just the two sides is have different
Yeah.
cross sections.
Yeah.
Yes,
Well,
no.
Yeah.
Crowd in the cross.
So, this is the
Yes,
typical,
Yes.
typical implementation of normal cross in the cross section view. This is the super elevation.
Oh, but it's not.
But how to change from the normal crown to super elevation?
Elevation.
Add more asphalt. That's on one side.
We can, from these figures, we can know.
Yeah.
Oh, like
So yeah,
in order.
in order.
Right.
So,
Is
zero
the
to
rotation is the axis. Is the center of the center of the line.
yeah.
When we the cross section is from normal ground to full super elevation. One side is changed from 5% to 2%.
Yeah.
When we this side is equal to this.
Yeah.
This is changed to
Yeah.
0%.
Yeah.
But this is not changed.
Yeah.
And from 0 to 2% and to 5%. But we should look at this is the super elevation runoff and the ground runoff, just like from. And this is super elevation runoff. We should know the length. And the super elevation transition is in this region. But we know that from and this the process is from 2% to 5%. Only this side is only in this region. But the other side is continue to change from 5 to 0 to 5 in the opposite direction. Yes or no? Relative gradient profile and cross-section view of the straight line rotation. Can you understand from this figure? It's just like normal ground, tangent runoff, the super elevation runoff. From the TS to the PC is, and the PC to SC. Design super elevation. This outside edge of the pavement, and this is inside edge of pavement. From this, we can know that NC 0 and NC and design, set design, and change. So this is with this figure we can know the relative gradient profile and the cross-section view of central line rotation. This is forces on a vehicle in a horizontal curve. We can do that friction force
Yeah.
for four tires of the car. Weight of the car. And the central force.
Centripetal force.
Yes. We can know, use this, we can know double key plus FF is equal to FCT. We can use this equation to calculate. And this we can divide it by W and cos half on two sides. We can get this. But the alpha is small. We can assume that alpha is equal to E. We can, from this figure, we can know that the vehicle forces in a horizontal curve. W is weight. N is normal force. F is friction force, all for tires. F is sine friction factor. Alpha is the amount of bending. R is radius of curve. So from this, we can know that R is should not less than this.
Yes.
Oh, there's another leaf vertical alignment. So this guy is over. And the high or low point based on the point distance from the PVC. We can use this equation to calculate. This is the parabolic function. The first derivative. And then we can change x is equal to this. It's right.
X is equal to minus P over 2 minus
Yes.
P over
Yes, it's right.
Right.
2 G and
2 times then B. With another 2, then L goes.
So from this we can know that x is equal to
2
this.
GL over G2, yeah.
Yes. This is the distance from the PVC to the high point, high or low point in feet. So this x from this equation we can get the we can get the high or low point of the vertical curve. Okay. Another useful vertical curve properties is one that gives the length of curve required to effect a 1% change in slope. Just 1% change in slope. Because the parabolic equation used for roadway elevations gives a constant rate of change of slope. It can be shown that the horizontal distance required to change the slope by 1% is this. We can look at A is absolute value of the difference in grade. We can use absolute and L. K value that is the horizontal distance in feet required to effect a 1% change in the slope of vertical curve. So we should compare this equation and this equation. The K value can also use to compute the high and low point locations of crest and sand vertical curves, respectively, like this. Now we can know that this equation we can use to calculate or compute the low or high point is equal to this. Yes or no?
Say that again, Akshay.
Like this. This equation is equal to this. But we can use another parameter k to determine. This is the horizontal, is a value, is the horizontal distance required to affect a 1% change in the slope. So, k value is just like not G, just L and G1 minus G2. It's an absolute value. So, this equation is equal to this. Okay, we have yes, 800 feet vertical curve that connect an entrance grade. Entrance grade is G1. And an exit grade of 1.9%. The PVI of the curve is located at station 146 plus 17.18 with an elevation of 314.22 feet. Also determine the location and elevation of the low point. We should know how to calculate it in 5 minutes.
Also, determine the location determine the location.
5 feet and is located at station 71.2.43. The PVC is located at station this and elevation. We should determine the minimum length of a vertical. Out. Determine the minimum length of a vertical curve. We should
Example 2. G1
G1
2%
is
4.2.
4.2%. G2 is minus 3.2%. And PVC elevation is 898.
0.73 feet.
73 feet.
Yeah.
We can plot use this. And X is station is this. we can know that station. The invert elevation of complete pipe located at the station is this, and this PVC is this. So we can got the axis station. So the derived elevation at station, including the diameter of the pipe, thickness of the pipe is pipe and thickness, and then necessary cover over the pipe. So we can derive the elevation at this station is PVC is like this, PV, and the elevation is 871.73 feet. For this 54.
Yeah.
3 inch
Oh,
was
okay.
in it, and 5 feet.
5 feet.
5 feet.
Yeah.
So we can got derived elevation is 884.26 feet. The parabolic equation that defines this vertical curve can be determined using the basic information like this. So we can get the L is this.
113.
So when we calculate or compute this elevation, we should, according to the parameters, we have known from these examples to calculate the minimum max. First, the vertical curves. Construction of a vertical curve is generally a costly operation requiring the movement of significant amounts of earthen material. Thus, one of the primary challenges facing highway design is to minimize construction costs, usually by making the vertical curve as short as possible, while still providing an adequate level of safety. So we should consider construction costs and should provide adequate level of safety. An appropriate level of safety is usually defined as that level of safety that gives drivers sufficient sight distance to allow them to safely stop their vehicle to avoid
Collisions with
objects obstructing their forward
motion.
So the provision of adequate roadway drainage is sometimes an important concern as well.
Yes.
So we should 3 aspects. It's just one is construction cost, another is adequate level of safety. Adequate road drainage is another. We can use this to determine SSD, stop side distance, is like this. Now, SSD stopping side distance V1 is initial vehicle speed. G is gravitational constant. A is the deceleration rate. G, road rate, is in percent. For up here and down here is obsolete. It's not right, it's minus. PR is perception per reaction time in second. We know V1 G PR and A deceleration rate. We can use these equations to calculate SST. For stopping side distance considerations for pressed vertical curves, there's two different conditions. For SSD is less than L and large than L. We can use different equations to calculate the L. But we should know what's the H. We should get or know the H1 and H2 and the AS. We can calculate the stopping side distance. This is different. Assumptions for design. H1 is the driver's eye heat. So it's usually about 3.5 feet. At the tail light heat.
This is why it's short people cannot drive.
Okay.
Because of the driver's eye height. Is that why short people cannot drive?
不可能开车
他
窗。
们开车可以。
It's just that we can use eyes to see the light of the tail of light.
Till night time.
所以它是根据统计来的。
统计来的，这个不能看。
所以说它这个是一般情况啊。So simplify equations we can use this. It's L for different conditions. We can calculate L with different equations. When we assuming L is larger than SSD, we can use K. We know SSD for a given design speed, assuming G is equal to 0. Key values can be computed for pressed vertical curves as you table. Thus, the minimum curve length can be obtained. Use this. Simplify margin A by the key value V from table 3. Like this. From this table, we can know, just like design speed is different stopping side distance. Rate of vertical curvature K calculated in design. So the rate of vertical curvature K is the length of vertical per percent and the variable difference in intersection grade. we get before. For example, for design speed is 50 miles per hour. The slope distance, stopping side distance is 425 feet. And the rate of vertical curvature we can get calculated is 83.7, and the design is slightly larger than calculated, but not less. You can know that?
Yes.
3 is 3, 6 to 1 and 7 is just a slightly larger than calculated. So we can use this to calculate K. This is the diagram of sloping side distance, the height of I1 and the height of object 2. The curve must be long enough so that the driver of a stand vehicle can also see an object before it gets within the maximum stopping distance for the designed speed of travel. This is a diagram to describe. It's the grade coming into PV and the grade out of PV1 T2 section point. And this graph so that you can know the minimum stopping side distance. Diagram of passing side distance. The curve must be long enough so that the driver of a standard vehicle can also see an oncoming vehicle within the C distance for the design speed of travel. It's just like this. Diagram of heat line side distance. From this, we can know that sag curveness, which is the minimum heat line side distance. And the curve must be long enough so that in dark driving conditions, the headlights of a standard vehicle illuminate the road a safe distance beyond the stop distance for the design speed of travel. So eliminates the road, the safety size distance is larger beyond the stopping distance. This is the headlight height above the pavement, maximum height angle. We should, according to different cars. Yes or no? Like SUV or truck. This is a diagram of rider comfort design. The curve must be long enough so that people in a standard vehicle do not experience excessive inertial force as they travel through the curve and the design speed. So this is another we should consider. Ride comfort. If the side is the curve, is less. And large speed, big speed, it may be uncomfortable when we pass this road. That's all. It's all about the horizontal and vertical alignment.